Hey guys, welcome back to another video. This one's going to be dedicated once again to the plug-in method. In case you don't know what that is from my last video, plug-in method is basically when you plug in your own values just to see if that would work with the problem. And it's also a lot easier and a lot faster than some of the other ways that you can use on the SAT or ACT. But I would caution you not to use it with every single problem. Use it more with the problems that I have in these videos, or if you see another example on the SAT or ACT where, it could be really fast for you to do it. Remember, don't pick outlandish numbers because you really want to be able to do these with quick mental math or quick calculator use. So let's get into it. This is the second video that I have on the plug-in method, and I did an example like this one in the first, but I just wanted to reiterate it just because these problems are usually in the harder section of the SAT and ACT, but really they're not that hard if you use the plug-in method. Right, so let's get started. The example that I use here is 5x minus 2 over x plus 3 is equivalent to which of these answer choices, right? So I would say that this is a plug-in problem just because they have a big fraction with variables and they're saying what is it equivalent to, right? And they're giving you a lot of answer choices over here. So when I'm thinking about plugging in a value, I'm going to think of it as, one, I want to get as close to 0 with that value as possible with the parameters in the problems, right? So they don't tell me that, or they don't give any, indication that x cannot be a certain number. So I'm just going to pick 0 for mine, just because I think that would be really easy with this problem, right? So let's start it off as x equals 0. That's the number I'm going to plug in, right? So it's 5x minus 2. So 5 times 0 minus 2 over 0 plus 3. And that equals, so 5 times 0 is 0. And then minus 2. And then 0 plus 3 is just 3. So that's what we want these to equal, one of these to equal if we were to plug in our x value of 0, right? That's what the plug-in method is for, really, in problems that say are equivalent to what, right? So let's get started with these answer choices. Our first one over here, or our first two actually, don't have any x's in them, so you can really just simplify them pretty quickly. 5 minus 2 equals 3, and then it's going to be 3 over 3, which is equivalent to 1. So A cannot be it because it does not equal that. It does not equal negative 2 over 3. And then we go over here, so it's 5 minus 2 over 3. 5 minus 2 over 3 is just 4 1/3, so it can't be that one either. And in case you didn't know that, it's just 5 minus 2/3 equals 4 1/3. So that can't be it either, right? So let's dive into some over here. I'm going to look at, judging by this, I know that I will be able to solve C faster just because it has smaller values it has smaller values around that. But what I want to look for, since I did 5 minus 2 over 3 over here, and it only got me, 4 1/3, and I'm trying to get all the way down to negative 2/3, I probably want to pick a bigger value just to see if I can get closer to negative 2/3, because right now I'm pretty far away from it, and if I plug 0 in for x over here, and that would give me just 5 minus 2 over x plus 3 again, or minus 2 over 0 plus 3. That's basically the same as over here, so I'm going to try D first, actually, right? Alright, so let's do 5 minus 17 over x plus 3. Let's do 5 minus 17 over, and then x in this case is 0, plus 3, which is equivalent to 5 minus 17 over 3. Alright, so we get to this point, and once you have a number that one doesn't have a denominator, you probably want to, because this one has a denominator of 3, this has a denominator of 3, you may as well put a denominator of 3 on that 5 too. So in order to do that, we're just going to make this 15 over 3, because in order to make a regular number have a denominator under it, just multiply it by that value of the denominator, multiply it in both places, so it'll be 15 over 3. And in case you don't know if you're totally right with that, you can always divide it. So 15 divided by 3 equals 5 again, so you know that you had the correct value. Right, and then this is really looking like our answer over here. So it's 15 over 3 minus 17 over 3. If you did the math for that, you would just get negative 2 over 3. And you know that that is the value that you're looking for, so D has to be that answer, all right? So let's do a quick recap of the plug-in method again. This is really used in a lot of types of problems that say this big fraction is equivalent to which of these answer choices. And that's a kind of a key word where you say, okay, I should probably use the plug-in method for this. All right, so in this example, I picked 0 just because, 1, it's really easy because it cancels a lot of things out if you were to multiply them by it. And 2, it's just a pretty simple number. It requires very little mental math, as I was saying before. That's what you're looking for in the plug-in number. Right, so I plugged in 0 into the original expression, and I got negative 2/3, and then what I'm looking for over here is if I were to plug in x is 0 into all of these, like which one would actually pop up with the correct answer, negative 2 over 3, all right? And in this case, when I plugged all these in, these two were pretty easy just because they didn't have any x's in them, so there was just solving. And remember, if you see in the answer choices, a lot of times, like what I did here is I kind of looked at it and I said, okay, let me solve this one actually first, just because of what I've already solved for. So I solved for 5 minus 2/3, and I said, okay, well, that only gives me 4 1/3. Obviously, that's not the right answer, so I can cross that out. But it also gives you kind of, it gives you a passage to think smarter about which answer choice you want to plug it into next, right? Because if this is so far away from the value that you're about to get, or the value that you want to get, wouldn't you want to plug it into one that would probably give you a bigger number to subtract from 5, right? And that's why I chose D to plug that 0 into first. And what I got from that, so 5 minus 17 over 0 plus 3, which is equivalent to 15 over 3 minus 17 over 3, which gave you the golden answer of negative 2 over 3, and that's how I got my answer for that. All right, I hope this video really helped you guys. Thank you for watching, and let me know if you have any more questions. All right.